Hello, my name is Chad Green. I'm at NASA's Jet Propulsion Laboratory, and this is a talk about the It's Live version 2 Global Glacier Velocity Data product. Now, It's Live is a big project. We have a number of different data products that we're working on, and we have lots of different collaborators who have contributed to this project. We're led by Alex Gardner at JPL. Today, I'm going to be talking about the glacier velocity data product, and it is global. By that, I mean we have characterized every bit of land ice that is at least 5 square kilometers in area and scoured the whole satellite image archive to develop a time series of glacier velocity for every glacier and ice sheet in the world. And the way that we do this is through a process known as feature tracking, which your eye is probably doing right now. Your eye is finding little features on the surface of this glacier network and tracking them as they move downhill. The way that feature tracking works for large-scale image processing is that we take an image of a satellite image of a glacier, come back a few days or a week later, a year later even, and then take another image from the same angle. With these two images, we take a little source chip from the first image and then scan around in the second image, looking for where the correlation is the best compared to the first image. And wherever that correlation peak exists, that tells us how those features have displaced from image 1 to image 2. And that displacement over the time between images gives us velocity. So a given image pair will produce a velocity field that looks a bit like something we see on the right-hand side, which is from the main trunk of Pine Island Glacier. And what we see here is pretty characteristic of what you might find in any level 2 image pair of velocities. So what we see is there's a diagonal line cutting across the bottom right-hand side, and that diagonal line just corresponds to the orientation of the satellite as it passed by, and it just happened to be going by at this angle. We also see bits of missing data. That's not uncommon. That can be a result of maybe a cloud in either one of the two images, or it can happen where there's just not a really good clear feature to grab onto, and or maybe the features were there in the first image, but a big snowfall event came in and erased them, and so we can't find them in the second image. Nonetheless, we do see pretty clear velocity data structure here, and if we stack up lots of these images, those holes end up getting filled, and we have a much more coherent idea of glacier velocity. So here's about what that looks like. If you've used GoLive data, for example, which is the predecessor to It's Live, you know that any given location can be passed by satellites from all different orientations, different paths and rows, and so what we see on the left-hand side here is just one single location on Byrd Glacier in Antarctica, and lots of different paths and rows have crossed over this one spot in different orientations. Now, It's Live anticipates ahead of time that, well, if we want an idea of how velocity changes over time, and we want that velocity field to be consistent over time, then what we do is we solve the glacier velocities on a consistent grid, regardless of the orientation of the satellite images. And so what that ends up doing is we create this data cube, like what we see on the right-hand side here, where every velocity measurement is on the same grid. So this is a 120-meter resolution grid. We stack them up into what's called a data cube. So with this, with a well-populated data cube, then it makes it easy to start taking averages or medians or find outliers. And we can create annual mosaics or overall mosaics. And this is a pretty characteristic mosaic like what we see for Greenland. Here we see in the 1980s, we have Landsat 4 and 5 data. And Landsat 4 and 5 was mostly collecting data around the coasts of Greenland. So this is a data density plot. So darker purple is more data, and it's a log scale. Through the 80s and 90s, we have a little bit of data around the coast of Greenland mostly. But then it's not really until 2013 when the launch of Landsat 8 really increases the amount of data available. From there, it's annual launches of Sentinel satellites, And now we're at the point where in 2022, there are parts of Greenland that have over 100,000 image pairs characterizing the velocity of this of a given location, over 100,000 image pairs in just 1 year. So we've quickly turned to this new regime of having a tremendous amount of data. Its live velocity mosaics, like the ones I was just showing for Greenland, they're available in lots of different regions around the world. They roughly correspond to the Randolph Glacier inventory regions. And that's what these colored squares are showing, is wherever you see these labeled regions, that's where we have mosaicked annual and overall velocities available. Outside of the RGI regions, we do see also these other little data cubes here and there, which didn't warrant a full mosaic generation, but the data is still available at the level 2 image pair level. If you want the velocity mosaics, you can find them at the NSIDC's website. There is an It's Live app, and it's just a matter of finding your favorite region and going through the menus to find out how to download that data. If you want to get down and dirty into the level 2 image pair velocity data, we also have tools available for that. Here, for example, is a simple Python command to get a list of all of the image pair data that meet some certain parameters. So in this example, the parameters are given by a geographic bounding box with certain dates of interest, and what we can do with this is just with a single line of code, you say request.get, get all of the data that meet these parameters. And what this returns is a velocity pairs list that has URLs to download the netcdf level 2 data. And there's no logins or passwords required. You can just run this line of code and get that data right away. Now, although we do solve the data in netcdf format, that's where they start, the image pair velocity data, and that's where you can get them and download them for processing on your local machine. I will say that it's becoming a very large data problem. So It's Live currently has over 36 million image pairs in the archive that have been processed and are easily available for download. And because new satellite images are being collected every day, and every image can be paired up with multiple images collected over the past year, there are about 20,000 more image pairs being added to the archive every single day. So it's a huge data problem. And the old regime of downloading every netcdf is probably going by the wayside if we're going to take fully advantage of all of this data. So while we do have the netcdfs available and will continue to do so, we also store this data as ZAR format. And this is, if you're unfamiliar with ZAR, it's a hierarchical data format. It's a lot like HDF5. It looks and feels the same way. But under the hood, the ZAR data format is actually storing the data potentially in multiple different files around the internet. And it enables concurrent read and write access. And you can do it really fast. So it's really optimized for cloud computing. And that is going to be the format that you're going to want to use if you're doing any kind of large data problem, and certainly if you're processing in the cloud. One of the things that ZAR enables us to do is create web tools, and like the one I'm about to show you. So here is a QR code. You could go to it, or you can just follow along. And so what that QR code takes you to is a really simple online app, which is, it opens an interface a lot like a Google Maps interface. And you can move the world around, zoom and pan, and drop little markers anywhere you want to. And from there, get glacier velocity data at those markers. You can manually move the markers with your mouse, or you can enter locations manually by typing them in. And for the data, you can filter by DT. That's the amount of time between images. Generally speaking, a shorter amount of time is going to have more temporal resolution. It can show you little spurts of velocity and coming back down. But shorter time intervals are associated with higher noise. So sometimes it's a matter of finding that sweet spot in the middle. You can also display by satellite or download the data as a CSV. This is actually really helpful if you're just wanting to do a quick exploration of the data and maybe plot it in Excel or task students with doing that. And then very crucially, there's an option to share a link, and that's this link that we see at the bottom of the page. That's what was linked to in the QR code. And in my own personal research, I have found this very helpful. So when I use it most is sometimes I get a quick question in my mind, like when exactly did Malaspina Glacier surge? Maybe I forget. So it makes it very easy you can zoom to Malaspina Glacier, drop a pin, find out what the velocity was doing at Malaspina Glacier at any given time, and then you maybe even get curious about, okay, what was going on at Malaspina's neighbor at the same time? Was it accelerating too, or was it doing something completely different? That's the kind of exploration that's really super easy with this app. And then once you find something that's interesting, you can permanently link to it with this share option. And I use it a lot when I'm collaborating with people in my group on Slack. I had to say, hey, check out this link. What do you think? And then they can start from the same point that you're starting from, and then they can explore it further on their own. So It's Live has a number of different tools, both in Python and Julia and in MATLAB. They have different levels of exactly what they're going to be able to offer of what you can do, but they are also constantly under development. So if you have a particular feature that you want, or if you want some kind of capability, let us know and either submit an issue or a pull request, and hopefully we'll adapt to whatever are the needs of the community. So as I mentioned earlier in this talk, It's Live isn't just about velocities. We have a number of other data products as well, including surface elevation change for the big ice sheets, Greenland and Antarctica, and time evolving ice masks for Greenland and Antarctica as well. So with that, I'm just going to say thank you, and if you have any questions at all, please feel free to reach out. We're usually available on GitHub, on Gitter, and by email. So reach out anytime, and thank you for your interest.